So now the next thing now, how can we find the terms for these n combinations? As I mentioned, using the same logic. You know, what we have is back to our formula as usual. That is n combination r, which is equal to n factorial divided by n minus r factorial. So now I want to find the value of n combination 2. I want to make it more interesting. So if I want to find n combination 2 here, meaning n remain as n, but our r here now is 2. So I will just substitute. That means that we have, so our n factorial remain as n factorial divided by my n is still n. So my r now is 2, is 2 factorial. R again is 2 factorial. So now we have n factorial divided by n minus 2 factorial. So 2 factorial, you know, recall in our previous example, and I've told you how to break down the factorial, that if I have 2 factorial, is nothing but 2 times 1, and that's going to be 2. So now, so you can see in the previous one, we have n minus 1 factorial, but now what we have is n minus 2, meaning I'll be decreasing it till when I reach n minus 2, so that they can be able to cancel each other. So meaning this is going to be n minus 1, n minus 2 factorial divided by n minus 2 factorial, then 2. So now easily this can cancel this now. So if this cancel this, all we have left now is n minus 1 all over 2. You can clearly see this is n bracket over n minus 1 all divided by 2. So that means the value of n combination 2 as required here is nothing but n bracket of n minus 1 over 2. So I can easily substitute the values here now. So if I substitute the value here, that means now here we have n minus 1 over 2. Don't be confused about this. If I have 1 raised to the power of n minus 1, as I told you, just like the way we have 1 raised to the power of n minus 1, it's still going to be 1, because anything raised to the power of 1, that will go to be 1. So here we have 1, and now what we have here is px all raised to the power of 2, or you can just break it down to make it easier. This is nothing but p squared and then x squared. So now 1 times 1 times 1, that one will give us 1. N times px, that will give us npx. Then this time what we have is n minus 1 all over 2 p squared x squared. So now they now say this expansion, you know, this is the first, as I mentioned, this is the first time. Our first time we got now is 1. The second time we got is npx. The third time we got is n of n minus 1 over 2 p squared x squared. They now say the term is nothing but from the polynomial, they say it is 1 plus 20x plus 160 x squared. So by comparison, meaning the first term here for the first term, you can see they are equal, right? So let me take note of this. Maybe when you are solving this kind of problem and you see that in the expansion, the first term you have here is not equal to the first term you have here, automatically that means your expression is wrong. So the first term we have here must be equivalent to this. So what we have here is 1. Then when we look at this, we can see this one is also 1. That means we are free to go. Now, the next thing now is to complete the second term. So can you check? What is the second term here? Exactly. The second term here is npx, and the second term here is 20x. So if I take it, that one is npx is equal to 20x. So we can see by comparison, what we have now, we can remove the x. Then what we have is np is equal to 20. And if you look at the third one by comparison, x squared by x squared, the coefficient, what we have is n of n minus 1 over 2 p squared is equal to 160. You can see we have made the problem more easier. What we are interested in here is how can we find the value of x, how can we find the value of n, and how can we obtain the value of our p. So by doing that, just clean this side so that we can have the solutions of that. So what we have now is you can call it by equations. What I have now is even clean this one so that I have enough space. Now the first one we have is np equal to 20. Let's call that one as equation 1. The second one we have is n minus 1 over 2 p squared is equal to 160. Let's call that one as equation 2. So just like the way we normally solve simultaneous equation, we know in simultaneous we have eliminations, we have substitution, we have graphical method. You know, in maths, we have different method of approaching simultaneous. But here, this is just like a product. If you look at this, and if you look at this also, so we can make any of this at the subject of the formula. If you like, you can make n at the subject and substitute back to the second equation. And if you like, you can make your p as the subject, then substitute to this equation. But to make it easier here, we can easily make our p as the subject and substitute its value to this equation. So from here, let's make our p as the subject. I have np equal to 20. If I divide myself by n, if this cancels, I can say p is equal to 20 over n now. Let's call this one as equation 3. That means whenever I see my p now, the value of our p is 20 over n. So if I look at equation 2, that means whenever I see p, the value of p is going to be 20 over n. So if I go here, that means that we have n minus 1 all over 2. So instead of writing p now, my p is what now? Yeah, exactly. What I have is 20 over n all squared is equal to 160. You can see, we just make one in the first equation and we want to substitute back to the second equation. So here we have n of n minus 1 all over 2. You know, this means 20 times 20 as well. N means n times n. So 20 times 20, that's going to be 400. N times n, that's going to be n squared equal to 160. So I think you are following. Now let's look at this. What I have is now, what we have is let's define this so that you don't get confused about this. Now what we have here is n minus 1 all over 2, 400 over n squared equal to 160. I can easily reduce this term. You can see 2 here, 1, 2 here is 200, right? So here is 1n, here is another, you know, this is n can cancel n squared, it's going to remain 1 here. So that what we have left now is n minus 1 of 200 over n is equal to 160. So now I can open the bracket. If I open the bracket, 200 times n, that's going to be 200n. 200 times 1, that's going to be 200 over n is equal to 160. What's going to be the next method, the next step now? Yes, exactly. You just have to cross multiply. If I cross multiply, that means that we have 200n minus 200. So if n multiply 160, of course, I will have 160n. So I can easily collect the like terms now. If I collect the like terms, which means that we have 200n minus 160n is equal to 200. So 200n minus 160, of course, that's going to be 40n equal to 200. You can see, you just have to collect like terms and group it down into one part. So now I'm looking for n divided by 40 divided by 40. So which means our n is equal to, so if this cancel this, 4 in 20, we are going to have 5. You can see how we obtain the n, the value of n is so simple. So now the value of our n is 5. You know, in the questions, we are asked to obtain the value of n at the same time the value of p. So now what we got from n now is 5. So I can easily substitute it to this equation 3 to have the value of my p. So in equation 3, what we have is our p is equal to 20 over n. So now our n is 5 now. If I put it here, that means that we have p is equal to 20 over 5, which means p is equal to 4. So we can conclude that means our n is equal to 5 and our p is equal to 4. You can see the beauty of our mathematics here. So either the terms, even if it is more than 3 terms, let's say we have first term, second term, third term, or fourth term, just make sure that you follow the same process. After using the combination method to expand the first 3 terms, then compare the result by what we are given as the result, then compare the first term by the first term, compare the second term by the second term, so that you can have your little expansions and little results. So in some cases, we may be asked to find a particular terms. Let's see some past questions so that we see how we can approach some problems. Let's talk about general expansion of the term. Maybe we have x plus y raised to the power of na. This is just a demarcation. What does that mean? It means here, as I told you, the purpose of this binomial and Pascal is to expand the terms if it is more than 2 or 3 or 4 or 5. So maybe in some problem, maybe they specify a particular power. Maybe in the expansion of x plus y raised to the power of 9, and I was asked to find a coefficient of maybe x7 or x6 or x9. How can we approach that? For example, maybe in the expansion of x plus 5 raised to the power of 9, and I was asked to find coefficient of x8, for example. So how can I do that? So instead of me wasting my time, expand all the terms, we have a general method or a general formula that we can just substitute. When you substitute, then you can have your result. How? For example, formula is given as this, as TR plus 1 is equal to n combination R, x raised to the power of n minus R, y raised to the power of R. Once you know this formula, that's why we firstly talk about how to use binomial with combinations. So here, n that we put here means the power that we have in that particular expansion. So normally when we have R, how we normally find out R. So this x that we have here is the first term, like for example, in a term like this. This is the first term and this second term. So it can be anything. It can be y, like for example, if it is a plus b raised to the power of n, for example. It can be anything. It can be numbers, it can be an alphabet. But we are going to follow it the same process. So meaning, this n that we put here, indicating the expansion that we have. It can be 5, it can be 6, it can be 7. Let's take a look at some past questions here so that we see how to approach that. Let's see some problem from Pascal here. They said, find the coefficient of x6, x raised to the power of 6 in x plus y raised to the power of 9. Let's look at this problem. It says find the coefficient of x raised to the power of 6 in the expansion of x plus y raised to the power of 9. Meaning, or maybe let's say, for example, maybe let's change this one to number so that it will be more interesting. So we have to find coefficient of x raised to the power of 6 in this expansion. In this expansion, we have when it is raised to the power of 0, when it is raised to the power of 1, when it is raised to the power of 2, 3, 4, 5, 6, up to 9. The question now specifies that I should find it at the point when it is raised to the power of 6. So meaning I have to be more focused on that, but I have to use the same logic, the same tactics, the same process. So how will I go about that? I'll just make sure I know the formula. If I compare them, I have x plus 2 raised to the power of 9. So now, by comparison with this, meaning our n here is going to be 9. Can you see? By comparison, our n is 9, our x is x. We are looking at that is the same thing. I know I told you it can be anything, and here y is 2. So using the formula, that's n combination R, x raised to the power of n minus R, y raised to the power of R. I will just substitute. So now my n is 9 now, meaning we have this one to be 9 combination. Our R is unknown because we don't know the value of R. 9 combination R. Our x is x here, x raised to the power of so our n is 3 remain as 9. That is 9 minus R. Our y is 2 here. That's 2 raised to the power of R. So after that, you can see we just substitute the values of what we have in the given problem. Our n is 9. Our x is x. Our y is 2. So therefore, I will just have to expand this. Let me make use of this place so that it will be more interesting. Okay, let me use this side. Now, what I have now is 9 combination R, x raised to the power of 9 minus R, 2 raised to the power of R. Now, I was asked to find coefficient of what? X raised to the power of 6. I will just equate. If you look at these 3 terms, which one have x here? You can see this one have x, so I will compare it to the one we are asked to find. We are asked to find the coefficient of x raised to the power of 6, right? So if I go here, that means I will just compare them. That's x raised to the power of 9 minus R is equal to x raised to the power over 6. Even if I was asked to find the coefficient of x raised to the power of 5, for example, I'll just take the result that x raised to the power of 9 minus r is equal to x raised to the power of 5. That is, whatever we are asked to find, we equate it to what we are looking for. So now, indices, indices, they will say this cancel this. Just take the power here as 9 minus r equal to 6. If I collect the like terms, that means that we have 9 minus 6 is equal to r, meaning our r is equal to 3. You can see how we got that. So now let's substitute back now. That means here, I can have this one now to be 9 combination. Now my r now is known to be 3 now. That's 9 combination 3, x raised to the power of 9 minus 3, 2 raised to the power over 3. So here, 9 combination 3, so x raised to the power over 9 minus 3, you can see that one is 6. Then 2 raised to the power of 3, we know it means 2 times 2 times 2, right? That is, we did that one in the previous examples. 2 times 2 times 2. So here, this one can just give us 9 combination 3, x raised to the power of 6. Then 2 times 2, that one is 4. 4 times 2, that one is 8. So leave this one as exercise for you guys. You can just know, I've mentioned it earlier, how can we find 9 combination 3? But let me quickly show you how to do that. 9 combination 3, that's n factorial, n minus r factorial. So n here is remain as 9. That is 9 factorial divided by 9 minus 3 factorial. 3 factorial here, so I can add this one to be 9 factorial. So 9 minus 3 here, we have 6 factorial, 3 factorial. And I told you how to evaluate factorial. So you can just follow the same process, how we normally find that. So to save our time, just find the value of 9 combination 3. Then we know that 2 multiplied by 2 by 2, that one is 8. So let's quickly find 9 combination 3. So if you check your result, what we have here is 84, x6, and I told you now 2 times 2, that one is 4. 4 times 2, that one is 8. So 84 times 8, we are going to have that one to be 672. 672, then x raised to the power of 6. So meaning the coefficient of x raised to the power of 6 in that expression is 672 of that particular value. So now, even with another problem, maybe it might not be x, it can be anything. Don't be confused about that one. It can be anything. Just follow the same process, the same pattern, the same way, the same process. So let me give you another example before we solve how to find the absolute terms. Let's look at this. They said, find the coefficient. Question 2, find the coefficient. Find the coefficient of x raised to the power of, let's say 4 in the expansion x plus 5 raised to the power of, let's say 6 this time around. So now they say find the coefficient of x raised to the power of 4 in the expansion x plus 5 raised to the power of 6. Just follow the same process using the same logic, the same method, the same formula. Now, by comparison with this, that means here, what's going to be the value of n here? Yes, exactly. So the value of n here is going to be 6. And what's going to be the value of x? X is still x, right? Yeah. So x is x. And what's going to be our y? By comparison with this, that means our y here is equal to 5. Good. So now, let's substitute back to the formula now. As the n combination r, x raised to the power of n minus r, y raised to the power of r. So now I have all the values. Let's be putting them one after the other. So my n is 6. That means that we have 6 combination r. My x is still remain as x raised to the power of my n is 6. That's 6 minus r. Our y is 5. That is 5 raised to the power of r. So now you can see we are trying to find the coefficient of x4. So this is x. I can just take it and equate it to what we are looking for. Meaning, what I have is x raised to the power of 6 minus r is equal to x to the power over 4. I told you it can be anything. Even it can be y, they can use any alphabet. So using indices, meaning 6 minus r is equal to 4. So if I collect like times, we have to collect like times here. If I collect like times, that means that we have 6 minus 4 is equal to r, which means r is equal to 2. So now we can now go back and substitute the value of our r now, right? So now, meaning we have this one to be 6 combination. So instead of writing r now, we have our r to be what? To be 2, exactly. As a 6 combination 2, x raised to the power over 6 minus 2, then 5 raised to the power over 2, because our r is 2 now. So that means now, this is our 6 combination 2, x raised to the power over 6 minus 2, that's going to be 4, 5 raised to the power of 2, no, that one is our 5 times 5, and of course, we are going to have 25. So please check your calculator with this. 6 combination 2, that one gives us a 15. So that means here what we have is a 15, x4, and 25. So let's multiply 15 and 25 together. If you do that, we are going to have that one to be 375 and x4. So meaning the coefficient of x4 here is going to be 375. So as I told you, it can be any alphabet. It can be x, it can be y, it can be w. Just follow the same pattern and the same process. So we also have another one when we be asked to find the terms. That is when we are expanding, maybe the first term or the second term or the third term. In that one, you just have to recall that what we have is r plus 1. You equate it to the term you are looking for. Then you find your r and substitute directly.